Suppose a simple random sample of size 75 is obtained from a population whose size is 30,000 and whose population proportion with specified characteristic is 0.4. Sampling distribution, you can check this. It's going to be approximately, I know for sure I'm not sampling. 75 is definitely not more than 5% of the population. And with a p of 0.4, I'm sure that it's going to n times p times 1 minus p is going to be greater than or equal to 10. Let's just double check it just in case you're not convinced. 75 times 0.4 times 0.6, 18. It's bigger than 10. And then let's see, the sampling distribution of p hat. Okay, so we're going to put in a sample size of 75 and a sample proportion of 0.4. Okay, so actually the picture that comes up is a binomial distribution. So but down below I've got my distribution. It says the sample proportion is approximately normal with a mean of 0.4 and a standard deviation of 0.057. So let's put that in, 0.4 for the mean. And 6 decimal places. Come on, man. That's so many. All right. The standard deviation of p hat is 0.056569. You happy? Yes. What is the probability of obtaining 36 or more individuals with a characteristic? Well, let's first change my precision down to 4 again. Okay. And so I'm asking, what's the probability that I'm getting? I'm going to do probability of above, and I'm going to put in 0.48. This is the approximate normal probability. Anyway, 0.0786. That's my probability. 7%. About 8%. What's the probability of getting 21 or fewer individuals? That is the probability of p hat being less than or equal to 0.28. Let's just put that in. Below 0.28. Hit enter. My probability is 0.0169. And that's that. Cool.